Hello, good morning. Good morning. Hello. Hello, is there anybody? Please reply.
Good morning, sir.
Good morning. Am I audible? My screen is visible. Everything good?
Yes, sir.
Okay. Okay, so we will start the fourth lecture on artificial intelligence overview. So okay, so what we have seen in the last lecture, we have seen about this, the Venn diagram of deep learning, machine learning, and artificial intelligence. So actually, we are going to deal with artificial intelligence. So it is nothing but mimicking the human behavior, which allows the machines to mimic the human behavior. And that is what is called as artificial intelligence. We have seen number of definitions, especially artificial intelligence as a branch of a computer science that is pursuing or creating the computers as intelligent as human beings. Then we have also seen about natural and artificial intelligence. So natural means occurring in nature and artificial means made by the people. Then beyond that, one of the definition by father of artificial intelligence, John McGathy, the science and engineering of making intelligent machines, especially intelligent computer programs. So artificial intelligence is the field of studies that synthesis and analysis of computational agent that acts intelligently. And then we started agent, so which is very important because we have a lot of points on agent. So which is nothing but which acts in the environment or it does something is called as the agent. So the agent is judged by its action, and agent acts intelligently. That means when it is appropriate for its circumstances and its goal, flexible to the changing environment and changing goal, it learns from the experience, and it can make appropriate choices given the perceptual and computational limitations. So this is what the agent is about. So we have also seen that the agent is judged by its action and enacts intelligently. There are 2 points which I do feel so are most important. One is a wetware and the other one is a hardware. So in humans, the computation is carried out, then it is called as a wetware, whereas in computers, when it is carried out, it is called as hardware. Then there are different goals of artificial intelligence: to create expert systems, to implement human intelligence in machines. And the central scientific goal of AI is to understand the principles to make intelligent behavior possible in natural or artificial systems. And then one of the central engineering goal of AI is to design and synthesis the useful intelligent artifacts. We actually build agents that act intelligently and which are very much useful in many applications. Then what contributes to AI? The AI is a science and technology based on the disciplines like maths, computer science, biology, physiology, linguistic, mathematics, computer science, and engineering. The three most important things that are associated with AI, or I could say that associated with the human intelligence of AI, are reasoning, learning, and problem solving. There could be one or multiple areas of the above disciplines that could be used to build an intelligent systems. This has been seen that what is the difference between programming with AI and programming without AI. So programming without AI can answer a specific questions, whereas a programming with AI can answer to generic questions. Then modifications in the programming leads to change in structure as far as without AI is concerned. Whereas with AI, the AI program can absorb new modifications. Then the third point, modification is not quick and easy, but in this case, it is quick and easy. So then next we saw AI techniques. So the most important problem is that the most important thing is that we do have some of the unwelcome properties regarding knowledge. That is huge. Knowledge is huge, unimaginable, well organized, well formatted, not well organized, not well formatted, as well as keep on changing constantly. And henceforth, to do this or to remove these issues, we can use the AI techniques. The AI techniques also elevate the speed of execution of a complex programs which are equipped with. Scope of AI. So we have seen that where the scopes of AI is as far as working is concerned. So we have seen education systems, chatbot systems, automatic grading, and healthcare, agriculture. Then we have seen in transport like self-driving cars, then home like OK Google, Alexa, Cortana, Siri is also there. So smart assistants to perform varieties of tasks like playing songs, asking questions, buying something on the line online. So these are some of the scope. Then AI in cybersecurity. As we know that the best example of cybersecurity is a cognitive AI that is being used in cybersecurities. Um by using AI, by using machine learning, deep learning, AI can be better for much resilience over time. Then manufacturing center, this is the most important sector where machine learning, artificial intelligence, and deep learning are working on, so that it will increase the growth of manufacturing industry, controlling various kinds of robots to do certain kind of jobs, then analyze data and make future predictions. So this could be some of the scopes of AI in manufacturing sector. Now we'll start with the new point, that is the approaches of AI. So basically there are 5 approaches in AI. The first one is the symbolic logic. Now these approaches means actually in what way are you going to represent this AI? Is there any methods? Is there any way to approach this AI? So there are 5 different ways in which you can approach AI. The first one is a symbolic logic. So you can understand from the word itself that there is something called as symbols, and these symbols will be used to apply some logics. So it's like a logic implementation using symbols, something like that. One of the ancient tribes, this symbolist, believed that knowledge would be gained by working on symbols, signs that stand for a certain meaning or event. So obviously, every symbol has some kind of meaning. Even if you go for alpha, delta, gamma, all these things are symbols. Um, even eta, efficiency for that thing. So these likewise, there are symbols which are having certain kinds of meanings, which stands for certain meanings or events. So people at that time used to believe that you can gain your knowledge using symbols. So if you're having a knowledge, you can easily represent it to the symbols. It could be like some kind of rules that could be applied with the help of symbols. So the symbolic logic is nothing but using those symbols for implementation of logics, and that is completely related with the knowledge. So if you're able to uh, draw the symbols, if you're able to represent the knowledge by using symbols, that to implement it with the logic, then it is called as symbolic logic. Then second, with the same thing that has been there, taking into consideration about the symbolic logic, how you can apply those symbols for reasoning also. Obviously reasoning is a part of a logic, so first two are nothing but they are same on the same platforms. So symbolic reasoning is nothing but the symbolists believe that knowledge would obtained by operating on symbols. So we have seen this and deriving the rules from them. By putting together complex rule system, you can attain a logical deduction of the result you wanted to know. So by applying the symbols for the logic things and applying the, and together we can use or apply the complex rules, the logical deduction of the results can be obtained, and that can help you to shape their algorithms to produce rules from the data. So that is what the symbolic reasoning is. It is as like as what the symbolic logic is about. In symbolic logic, deduction expands the scope of human knowledge, while induction increases the level of human knowledge. So there are two things in case of symbolic logic. As far as the reasoning is concerned. The symbolic logic is concerned, we can say that there are signs that stands for certain meanings. But in case of symbolic reasoning, there are few things that are related with is deduction and induction. So what is deduction? Deduction expands the scope of a human knowledge. So what kind of scope the human knowledge has? It is about the deduction, where induction actually increases the level of the human knowledge. So deduction and induction are the two things that are related with the symbolic reasoning. Induction usually opens up new areas of exploration, whereas deduction explores those areas. So induction is actually helping you to explore new areas, whereas deduction explore those areas. Means induction comes up with the new areas and the exploration will be done by the deduction. So this is basically the symbolic reasoning. So it comes under one point only, that what is basically it is nothing but symbol. The language that is can be used to represent the logics or represent the reasoning is nothing but symbol, and the symbols are nothing but the signs that stand for certain meaning or event, and they are implemented in such a way that you can draw some rules from them also. This is also very much important. So when we apply for the logic, you have these kinds of symbols that can be useful to draw rules from them. And as far as symbolic reasoning is concerned, then you have symbolic logic using deduction and induction. So deduction is the scope of human knowledge, whereas induction is nothing but increasing the level of human knowledge. So once you have induction, you can use deduction to explore those areas. This is what it does actually mean. So it is written as two approaches, but they are basically only one approach. Then second approach is the connections that are based on neurons of the brain. So obviously the artificial intelligence is nothing but it's a mimicking of a human brain, human behavior, and henceforth there will be always a connections with the neurons of the brains. So you're going to mimic the human brain, human intelligence, and human behavior. So the approach definitely is going to have a connection based on the neurons of the brains. Now, the connectionists are perhaps the most famous of the five approaches. This approach attempts to reproduce brain functions by using silicon instead of neurons. So in humans, we have neurons, but as far as in artificial intelligence is concerned, we are replacing those neurons in human brain with the help of silicon chip. So there we have neurons that interacts with each other and take an action, take an decision. In case of artificial intelligence, you can see that there these uh, uh, neurons will be replaced by silicons. Essentially, each of the neurons build on an algorithm that build the real world counterparts. So each of the neuron play a very important role and solves small pieces of problems. Using multiple neurons in parallel solves the problems as a whole. So there will be few neurons which will be solving small pieces of problems, and together when they work out together, or the multiple neurons when work out together, you find the problem as a whole can be solved. So this is how the actually human brain works out. So exactly we want to mimic it in case of artificial intelligence. So the approach will be using silicon instead of neurons, as the neurons are used to build the models that real world counterpart. Now when we go for the AI, the main goal is to keep changing the weights and biases until the actual matches the output target. So in case of artificial neural network, we have already seen that there is a neuron, uh, the brain, a single unit of a brain is nothing but neuron. So neuron is having an inputs x1, x2, x3. Then we have a weight which is multiplied with these inputs, and then the bias is also added. So in case of feed forward method, we go from input side to the output side. But in case of back propagation method, we go from output side towards the input side. So in case of back propagation method, what it does is that in order to eliminate the error, we go by back propagation and keep on changing the weights and bias values so that we can get less error. So exactly same thing is happening in this neural network also, where actually the in order to match the output to the target output, you keep on changing the weights and biases. And the artificial neuron fires up and transmits its solution to the next neuron in the line. So obviously there are some silicon chips that are acting as a neuron, which will transfer the information from one silicon chip to the other silicon chip, like neurons transfers the information from one neuron to the other neuron. Each the solution produced by just one neuron is a part of a whole solution. So obviously one neuron or one silicon is a part, whereas there will be number of silicon chips that will be operating, multiple chips will be operating together, and they will be producing a whole solution. Each neuron send information to the next neurons until the neurons make up it to the final output. Such a method proved most effective in human like tasks such as recognizing objects, understanding written and spoken English, and interaction with the humans. So obviously this is the way the neuron works, and this is the way the silicon chip is going to work in artificial intelligence. So the same mimicking of human brain is done as far as the artificial intelligence is concerned. So how mimicking is done? There we have neurons, here we have silicons. The neurons are going to transfer the information from one neuron to the other neuron, and it keeps on passing till it goes to the output. Similarly, it happens in artificial intelligence with the silicon chip. So obviously few of the neurons working out and then multiple of neurons working together to produce a whole output is the most important target of this neural networks. So where could be used, where it could be used, obviously it could be used which is effective in human like task like we do, like human does. Similarly the artificial intelligence will also do. So what human does, obviously the same thing can be done, or same thing can be carried out by the human with artificial intelligence. So what it can be done, obviously these neurons in the brains will help you to recognize objects, to understand the written and spoken language. So obviously the languages which you read or which you write down, and then also interacting with the humans. These are some of the things that will be useful as far as connections of based on neurons of the brain. So this is the most famous and most important approach of the one of the most important approaches of the AI. Then the fourth one is the evolutionary algorithm that test variations. Now, the evolutionary algorithm means which has been evolved and which is going to actually test some variations. So how it is going to test, we are going to see in this approach. So the revolutionary relied on the principles of evolution to solve problems. In the other word, this strategy is based on the existence of the fittest, that is removing any solution that does not match to the desired output. So obviously the strategy is going to be in such a way that if suppose if there is any kind of work which you carried out and apply a particular solutions to solve that, but next time it is not necessary that the same solutions could be applied to that problem to be solved. So you're going to remove the earlier solutions and then apply the newer one. Exactly the same thing is there. So the test variations you can easily check with the evolutionary algorithm, like removing any solutions that does not match to the desired output. A fitness function determines the feasibility of each function in solving the problem. Using a tree structure, the solution method finds the best solution based on the function output. So when it is going to change the solutions, so it is going to follow like a structure of the human beings, like like a tree. Suppose I'm thinking that this is to be solved. If it is yes, then we'll go with this. So again, with when we go to that side, there will be again two options, yes and no. Now this time if it is no, then there will be no and it will stop. So it is like a tree structure and the solutions can be found out, right? The winner of each level of the development has to create tasks for the next level. So each task which is completed is going to create a new task to the next level. The idea is that the next level will grow closer to the solving problems, but may not solve it completely, which means another level is needed. So it is not necessary that each and every level will give you the solutions. So sometimes it is needed that the next level is needed because till that time you haven't got the solution. Exactly same thing happens in your brain. कभी कभी हम लोग ये सोचते हैं कि ये सॉल्यूशन तक पहुंच गए हैं लेकिन ये कुछ कंप्लीट नहीं लग रहा है. सो आप नेक्स्ट लेवल की तैयारी करते हैं कि इसके आगे और क्या लेके जाए. सेम थिंग एग्जैक्टली वी आर मिमिकिंग. This particular tribe relies heavily on recursion and languages that strongly supports recursion to solve problems. So obviously the main ultimate aim is to solve the problems. An interesting output of this strategy has been algorithms that evolve. One generation of algorithms creates the next generation. Likewise, one neuron gives the task to the next neuron and then gives it to the output. It reaches to the output. So same thing happens here also. An interesting output of this strategy of this algorithm is to one generation algorithm creates to the next generation algorithm. So this is how it goes on, and hence it is called as the evolution, because you're evolving and coming up to the new solutions. Then the fifth one is a Bayesian approximation. Obviously, there are 5 approaches. So I said that 1 and 2 are same thing. So that's why it's looking at 6 approaches here, but there are 5 approaches. Then Bayesian approximation. So obviously the Bayesian have been the word that has been, you have already learned in machine learning algorithm that follows the Bayes algorithm, Bayes theorem. And according to the Bayes theorem, it can be useful for the classification purpose. So here also one of the approach of AI is a Bayesian based. So the Bayes theorem will come into the picture, and when Bayes theorem comes, the probability concept comes here. So it is the probabilistic model algorithm. We have already seen that it is one of the probabilistic algorithm, and that is nothing but Bayesian algorithm. So learning was not assured, but rather occurred as a continuous update of previous assumption that become more accurate. This notion inspired Bayesians to adopt statistical methods and in particularly derivations from Bayes theorem. So that I have explained you, which helps you to calculate probabilities in specific situations. Exactly same thing. It is based on completely probability. So any situation can be tackled based on the probability concept, any specific situations. For example, by looking at the card of a certain pseudo, the starting value of the random sequence after 3 other cards of the same seed are drawn from a deck. Now, this is the example, just an example how the Bayesian theorems work out. So if the probability of using the cards are similar, what you have been saying in the earlier probability concepts, where you can draw a number of cards from pack of 52 cards, and then what is the probability of getting queen, what is the probability, all those things we have seen. That is the same example, that is of the Bayesian approximation. Now Bayesian approximation, the word itself says that you're going to approximate the output which may be matching up the target output. So that is what the Bayesian approximation is. Then the sixth is the systems that learn analogy. Now, analogy is a very important concept. If you understand how the analogy works out to be, I'll give you best example is that sometimes if you want to learn some kind of parallel processing, and the data is going from one pipe to the other pipe, or the data is moving from one section to the other section, and if you're able to explain the whole concept using the water pipelining. So actually what you're doing is that you're creating an analogy to explain the concept of parallel processing. So you can take an example of how water is feeded to the city, how it goes to each and every tap of the house. Same thing exactly what happens in parallel processing, how the data is sent from one section to the other section. So these are the things that can be explained with the help of analogy. So analogy is nothing but the example that you can correlate with the concept. And then if you remember the analogy easily, you can remember the whole concept. So similarly, the systems that learn analogy can be useful in a can get a very good help in taking decisions. So obviously humans also learn from analogies. So the systems can also learn from the analogy. The analysts use kernel machines to recognize patterns in the data. By recognizing the patterns of set of inputs and comparing it to the known outputs, you can create a problem solution. So obviously there are some patterns in the data. Each and every data has some kind of pattern. That may be a random pattern or that may be some kind of unrandom pattern. But now what happens is that the machines can recognize the patterns, and then it will compare it with some kind of patterns to the output. If you're going to help in order to correlate those patterns, you can easily go to a problem solution, right? The goal is to use equality to determine the best solutions to the problem. So obviously the most important thing is that how you're going to determine the best solutions, how you're going to tell the best solutions to that problems. It is the kind of a reasoning that determines whether a particular solution was due in a particular situation at prior time. So obviously, if that I've said that there are some situations where one solution can work out, but in the same kind of situation, that solution may not work. So it might have to go for the another situation at a prior time. Using that solutions for similar situations should also work, but at the same time, that solution can be also useful to the similar situation can also work. So you can actually study the system using the analogy, and that is what the concept of the system that learn analogy means. I do feel so you might have understood all these concepts. So once again, we'll revise this. The approaches of AI. So we have seen symbolic logic. The symbol is nothing but the sign that stands for certain meaning or events. Then symbolic reasoning. As far as reasoning is concerned, here there is a part of deduction and induction. Deduction actually is nothing but the expands the scope of the human knowledge, whereas induction increases the level of the human knowledge. So induction usually opens up the new areas, whereas deduction will explore those areas. And this is the connection based on the neurons of the brain. This is one of the most famous of all the five approaches that can be useful for, and that are effective in human like tasks such as recognizing objects, understanding written and spoken languages, interacting with humans. So some of the neurons can solve some small pieces of the problems, and then multiple neurons in parallel can solve problem as a whole. That is the most important thing. And this is the evolutionary algorithm for the test variations. So using the tree structure, the solution method finds the best solution based on the function output. And the most important thing is that here one generation of algorithm creates the next generation. And then the Bayesian approximations is nothing but it is completely based on the Bayes theorem, and that helps you to calculate the probabilities of the specific in a specific situations. So that is the most important thing of Bayesian approximation is. It is also called as the probabilistic algorithm. Then the system that learns analogy. So there are two things which comes out to be here is that by recognizing the pattern of the inputs and comparing it to the known outputs, you can create a problem solutions. And using that solution for similar situations should also work. So these are some of the five approaches of AI. Now we'll go to the problems of AI. Now, so as we are also seeing the foundation, the scope of AI, the approaches of AI, the techniques of AI, but it's not necessary that everything is good. There will be some problems of AI also. So what are the problems of AI? The first is lack of technical knowledge. Obviously, the AI field is quite a complicated field. It's complex subject to understand, and henceforth we know actually we should know. It's difficult to know some kind of expertise in artificial intelligence. So the lack of technical know-how is hindering the adoption of this domain in most of the organization. So the lack of knowledge as far as AI is concerned is not helping any organizations. So to integrate, deploy, and implement AI applications in the enterprises, the organizing must have the knowledge of the current AI advancement and technologies as well as its shortcomings. So everything should be known by the organization if it is to be implemented. So that is not the case. So the lack of technical knowledge regarding artificial intelligence is the big problem. Even in industries, you'll be finding a lot of people being not knowing anything about AI, or it might be like implementing AI in industry is something different. So there is a lack of knowledge of AI, and that's what it is hindering the adoption of this domain. Second is the price factor. Again, the second most important is that how much expenses the industries will be having if they are going to adopt this AI. That is also the most important case. And is it really a costly affair? So small and mid-sized organization struggles a lot as it comes to adopting AI technologies, as it is a costly affair. So as far as small and medium industries are concerned, they will find it difficult. But as far as the MNCs or the top industries, they can find it there. But again, it's a little bit of expensive for them to accept also. And some of them are started adopting. That is a very good sign. So even the big firms like Facebook, Apple, Microsoft, Google, Amazon, they are having a separate budget for this artificial intelligence in order to implement the AI technologies. Then comes data acquisition and storage. So obviously in artificial intelligence, you have lot of data that is going to be gathered. So that data acquisition problem is going to be there in AI, because that's one of the most biggest problem in artificial intelligence, is to acquire then data and then store it. Business AI system depends on sensor data as its input. For a validation of AI, the mountain of sensor data is collected. So we'll be having tremendous data that is coming from all the sensors. So how to acquire this data and where to keep this data is the most important thing. Irrelevant and noisy data set may also cause obstruction as they are hard to store and analyze. And obviously at the same time, if you have been collecting huge amount of data, there is always a chances of noise getting into your data. So the noisy data, to tackle those noisy data is also a very tough task, because the data is not a small data, it's a huge data, it's tremendous data. So all these factors creates little bit of problems of implementing AIs in industries. Then comes a rare and expensive workforce. So even if you're going to have, even if you're having knowledge of AI, it's been difficult for to implement or to give the knowledge to the workers, and to hire those workers, you have to pay them a lot. So it is a rare and expensive workforce. Obviously the people who are expertise in AI, they are very rare. And the second most important is that they are very expensive to hire. So the adoption and development of AI technologies requires specialists like data scientists, data engineers, and other SMEs like subject matter experts. So you require these people to hire. These experts are expensive and rare in current marketplace. So you will be finding an artificial intelligence engineer or a data scientist or data engineer, or other the subject matter experts to be very less. They are shortage in the market at the moment, and they are very expensive. Small and medium sized entrepreneurs fall short of the tight budget to bring the manpower according to the requirement of the project. So if the project is very huge project, then you required sufficient manpower. So in case of small and medium sized enterprises, it is really difficult to scope up with the budget also, as well as manpower also, in order to implement the projects. Then comes the issues of responsibilities. The implementation of AI application comes with great responsibility. Any specific individual must bear the burden of any sort of hardware malfunction. So obviously there should be a few people who should take out the responsibilities about implementing. Also about hardware malfunctioning, they should be taken. Earlier, it was relatively easy to determine whether an incident was a result of action of user or developer or manufacturer. So without AI, if you go see, then if there is some kind of error or if some kind of issues are there. So you can easily judge it from whether it is from the user side, from the developer side, or manufacturer side. But in case of AI, it becomes difficult actually where the issue is, how to manipulate that issues, and from where exactly the issue has come up. So all these problems is nothing but about the issue of responsibility. Then comes the ethical challenges. One of the major AI problems that are yet to be tackled is the ethic and morals. So as far as AI is concerned, there has to be some ethics and morality that has to be followed. The way how the developers are technically grooming the AI bots to perfection, where it can be flawless, imitate human conversations, making it increasingly tough to spot a difference between machine and real customer service representative. Now, what happens is ethically challenge means what is happening that the humans mimicking of the human intelligence in a robot or AI bots is increased so way that it's been difficult to differentiate whether a machine is speaking or whether is human is speaking. So all these ethical challenges will come up as we will go in depth of AI. So these are some of the problems of AI. Then comes the lack of computation speeds and legal challenges. So lack of computation speeds, AI, machine learning, and deep learning solutions require a high degree of computation speeds offered only by the high-end processors. So if you want to tackle the programming that is based on AI, machine learning, or deep learning solutions, so they required a very high computation speed, and you cannot achieve it on a normal computer. So you need very high-end processors to tackle these things. So that means you have a larger infrastructure requirement, and the pricing associated with the processor has been a hindrance in the general adoption of AI technology. So if the high-end processors has to be adopted in order to gain the computation speed, the processor you require larger infrastructure, right? And then it becomes difficult for the adoption of such kind of AI technologies. So there are a lot of issues that have been there in the market as far as AI acceptance is concerned. Then legal challenges. So beyond this, there are some legal challenges also. The AI applications with anonymous algorithm and data governance can cause legal challenges in the company. So the AI application with erroneous algorithm, there will be some erroneous algorithms. And then the data governance is also an issue which could be a legal challenge for the company. This is yet again one of the biggest AI problem that developer faces in the real world. मेरे ख्याल से सबसे ज्यादा जो problem है वो अभी legal का ही है, because there are no such as rules, or there are no such as base that is been there as far as the AI application is concerned. So when AI application is there, there will be some legal challenges also. And the last two is AI myths and expectations. So there are very myth that has been across AI. There are myths means normally the people are not ready to accept this artificial intelligence, as because the people are thinking that this if AI will come into the picture, they will replace the human jobs. So that is the most important thing is this. There is a quite discrepancy between actual potential of AI and expectations of the generation. So what is been shown and what is been implemented, also there is a gap between that. And also media says about AI that it will replace human jobs because of the cognitive capabilities. Difficulty of assessing the vendors. So obviously if you're implementing AI, it doesn't it's not the same thing that the other industries which you're dealing with they will apply AI. So there will be always an difficulty in assessing the vendors in an emerging field where each procurement is quite challenging. Is in as an AI is particularly vulnerable. So business face a lot of problems, know exactly how they can use AI effectively, as many non-AI companies engage in AI washing some organizations and overstate. So that is what, like if an industry, if one of the industry that adopts AI, and then there will be some industries which will be not adopting AI. So what will happen, the non-AI companies and AI companies, how they will engage with each other in order to go for a business, it's been difficult. So there will be always a difficulty in assessing the vendors. So this is what we have seen up till now, that is problems of AI. So now in the next lecture, we'll actually see actually see the intelligent agents, or we can say the agent part will come into the picture, and from where actually the actual artificial intelligence will begin. So just a moment. I'll take attendance.